Dear students, welcome to first lecture of Applied Physics. In this lecture, we will study the waves. We will cover the definitions, characteristics of waves, and its classification. So let's start. What is a wave? Yes, a wave is the vibration or disturbance in space. You can also describe the wave as the disturbance that travels through a medium. Through wave, energy is transferred, and all this done without transferring matter. If we classify the waves, we can classify them as electromagnetic waves and mechanical waves. Electromagnetic waves differ from mechanical waves in that they do not require medium to propagate, and mechanical waves need medium for propagation. Electromagnetic waves. As the electromagnetic waves do not need medium to propagate, so these waves can travel through matter or empty space. Radio waves, microwaves, infrared waves, visible light, ultraviolet rays, and X-rays are the example of electromagnetic waves. Mechanical waves. Yes, these are the waves which need medium to propagate, and energy is transferred through vibration of particles. Water waves, earthquake, seismic waves, sound waves, waves that travel down a rope or spring are the example of mechanical waves. If we classify the wave, we can classify them in transverse waves and longitudinal waves. This classification is based on how particles move through them. In transverse wave, particles move perpendicular to the motion of wave, and in longitudinal waves, particles move parallel to the motion of the wave. Let's see the characteristics of waves. First, the wavelength. Wavelength is the distance between corresponding points of two consecutive waves measuring from crest to crest, trough to trough, or zero crossing to zero crossing. Amplitude. Every wave has amplitude. The amplitude is defined as the displacement of points on a wave, which you can think of as the degree or intensity of change. And this maximum displacement is measured from the equilibrium position. The given diagram shows the amplitude. Frequency. The definition of frequency is pretty simple. The number of waves that pass a fixed point per second is called frequency. Or frequency is the number of times something happens over a period of time. It is measured in hertz, and mathematically we can write f equal to 1 over t. In the diagram, we can see the higher frequency have short wavelength and low frequency have long wavelength. Period. Period is the time between oscillation of wave, or a time required for a wave to travel a distance equal to wavelength. Period is the reciprocal of frequency. Its unit is second, and mathematically we can write it as t equal to 1 over f, where f is the frequency. Wave velocity. Distance travel over period of time. And how we measure distance when we go to wave, that is wavelength or lambda. And how we measure time when it comes to wave, yes, that's going to be a period. So we simply divide the wavelength by period and got the velocity.